Welcome to G Fun Facts Online. Imagine a desolate stretch of Interstate 80 at 2 in the morning. A convoy of three massive 80,000-pound Class 8 semi-trucks hurtles down the asphalt at 65 miles per hour. Visually, they look like any other freight trucks, but a closer inspection reveals something extraordinary. The distance between them is a mere 30 feet. To put that into perspective, that is a gap that would be absolutely suicidal for human drivers at such extreme speeds. In the lead truck, a driver monitors the road, hands resting lightly near the wheel. But in the two trailing trucks, the driver's seats are entirely empty, or the drivers are resting, reading, or logging off for the night. These trucks brake, accelerate, and steer in perfect, telepathic unison, functioning not as three separate vehicles, but as a single, multi-segmented organism. This is not a scene from a science fiction film. It is the very real, rapidly unfolding reality of vehicle platooning in the modern era. As global supply chains face unprecedented pressure, fuel costs remain incredibly volatile, and environmental regulations tighten across the globe, vehicle platooning has emerged as one of the most transformative developments in the history of transportation. By bridging the gap between advanced aerodynamics, artificial intelligence, and instantaneous digital communication, platooning represents the networked future of autonomous convoys. It is a massive paradigm shift that is actively rewriting the rules of logistics, redefining road safety, and paving the way for fully autonomous highways. To truly grasp the sheer magnitude of this transportation revolution, we need to look under the hood of the technology, examine the profound economic and environmental benefits, and navigate the complex roadblocks that stand between today's driver-assisted convoys and tomorrow's fully autonomous freight networks. Let us start by breaking down the mechanics of this hive mind and exactly how platooning works. At its absolute core, vehicle platooning is the linking of two or more vehicles in a convoy, using state-of-the-art connectivity technologies and automated driving support systems. These vehicles automatically maintain a set, close distance between each other, constantly communicating real-time data to ensure perfectly synchronized movement. The true magic of platooning lies in its ability to eliminate the most unpredictable element of driving, which is human reaction time. Consider this. A human driver takes roughly 1.5 seconds to perceive a hazard and apply the brakes. At 65 miles per hour, a truck travels over 140 feet before the brakes even begin to engage. If a truck is following only 30 feet behind, a crash is mathematically unavoidable. But in a platoon, the digital reaction time is measured in mere milliseconds. If the lead truck detects an obstacle and applies the brakes, the trailing trucks brake simultaneously, maintaining that 30-foot gap with flawless robotic precision. This incredible hive mind is made possible by a convergence of several critical technologies working together in perfect harmony. First, we have vehicle-to-vehicle, or V2V, and vehicle-to-everything, or V2X, communication. This communication network is the literal lifeblood of a platoon. V2V technology allows vehicles to broadcast and receive vital data regarding speed, heading, braking status, and acceleration up to 10 times every single second. Moving beyond just the vehicles themselves, V2X encompasses communication with the surrounding infrastructure, known as V2I. This includes talking to traffic lights, toll booths, and the broader cloud network. Driven by advanced 5G and early 6G networks, this ultra-reliable, low-latency communication ensures that the invisible electronic tether connecting the convoy is absolutely never broken. To give you an idea of how fast this is growing, as of 2025, V2V communication accounted for over 57% of the platooning technology market, supported by thousands of new technological patents focused specifically on creating unhackable, instantaneous data streams. The second piece of the puzzle is cooperative adaptive cruise control. You might be familiar with traditional adaptive cruise control, which uses radar to maintain a safe distance from the vehicle ahead. Cooperative adaptive cruise control takes this a massive step further by integrating that V2V data we just talked about. Instead of reacting to the physical presence of the vehicle in front, cooperative adaptive cruise control reacts to the digital intent of the lead vehicle. When the lead truck makes the decision to brake, the command is instantly sent to the trailing truck's powertrain and braking systems before the lead truck even begins to physically slow down. The third pillar is sensor fusion, which involves LiDAR, radar, and machine vision. While V2V handles the coordination between the trucks, the vehicles must still understand their physical environment. An incredibly robust suite of sensors acts as the eyes of the platoon. Radar is used to penetrate thick fog and heavy rain to accurately measure distance and velocity. LiDAR paints a high-definition three-dimensional map of the surroundings using millions of laser pulses, and high-resolution optical cameras read lane markings, traffic signs, and perhaps most importantly, erratic movements from non-connected passenger cars around them. Finally, we have quantum and predictive artificial intelligence algorithms. As we push deeper into the late 2020s, the algorithms governing these platoons are becoming astonishingly complex. Researchers are now employing advanced predictive models, such as quantum long short-term memory neural networks. These models analyze massive amounts of historical data, road topography, and real-time sensor inputs to actually predict the future vehicle dynamics of the lead truck. This incredible predictive power allows the trailing vehicles to adjust their behavior dynamically, optimizing control strategies, maintaining what engineers call string stability to prevent that dangerous slinky effect of delayed braking, and ensuring maximum fuel efficiency regardless of the weather or the gradient of the road. So what are the driving forces behind this? Why is platooning taking over the industry? The explosive growth of the truck platooning market is undeniable. It is projected to surge from roughly $200 million globally in 2026 to over $1.16 billion by 2035, and nearing a staggering $7.9 billion in the United States alone by 2036. This explosive growth is not being driven by the mere novelty of the technology. It is being driven by cold, hard economics and an urgent, pressing environmental mandate. Let us talk about aerodynamic alchemy and fuel economics. The physical principle behind platooning is slipstreaming or drafting, a concept that is very well known to professional cyclists and stock car racers. When a large, blocky object, like a Class 8 semi-truck, moves through the air at highway speeds, it actively pushes a massive wall of air out of the way. This creates a high-pressure zone in the front and a turbulent, low-pressure wake in the rear. This aerodynamic drag forces the incredibly large engine to burn massive amounts of diesel simply to maintain speed. However, when trucks link up in a platoon, their aerodynamic profile changes drastically. The lead truck still breaks the air, but the trailing trucks tuck neatly into that low-pressure wake, virtually eliminating their frontal air resistance. Surprisingly, the lead truck actually benefits as well. The presence of the trailing truck smooths out the turbulent wake behind the leader, actively reducing rear drag. The real-world financial savings from this are absolutely staggering. Studies in real-world pilot programs reveal that the lead truck experiences fuel savings of around 4 to 5%, while the trailing trucks can see massive efficiency improvements of 8 to 13%, and sometimes up to 17% in highly optimized corridors. In the fiercely competitive logistics sector, where fuel is a primary operational expense, these margins represent the critical difference between struggling to survive and thriving. At an average diesel price of $4 per gallon, a two-truck platoon traveling 100,000 miles annually could save a following truck up to $12,000 a year. When you extrapolate those savings across corporate fleets consisting of thousands of trucks, the financial incentive to adopt this technology becomes entirely undeniable. Beyond the economics, there is a massive environmental imperative. The transportation sector is one of the absolute largest contributors to global greenhouse gas emissions. In regions like the European Union and the United States, heavy-duty vehicles account for a wildly disproportionate amount of transportation-related carbon dioxide emissions. For example, heavy-duty trucks account for about 30% of carbon dioxide emissions from road transport in the European Union, despite making up only a small fraction of the total vehicles on the road. Platooning offers an immediate, highly actionable solution to this global crisis. Extensive tests by major vehicle manufacturers have confirmed up to 12% overall emission savings simply by minimizing that aerodynamic drag. System dynamic modeling indicates that the widespread adoption of platooning in the United States alone could save nearly 292 million metric tons of carbon dioxide emissions within just 15 years of its mainstream introduction. As governments enforce increasingly stringent regulations, such as the European Union's demand for a 15% reduction in carbon dioxide emissions by 2025, logistics companies are actively turning to platooning not just to save money, but to remain legally compliant. Another major factor accelerating platooning is the global supply chain bottleneck. The global logistics network has been severely strained by a chronic and worsening driver shortage. Back in 2025, the American Trucking Associations projected a massive deficit of over 80,000 drivers in the United States alone, with very similar labor crunches causing huge port delays across Europe and the Asia-Pacific regions. The lifestyle of a long-haul trucker involves weeks away from home, grueling hours, and extremely high stress, which has made industry recruitment incredibly difficult. Platooning, particularly in its more autonomous phases, provides a highly powerful pressure release valve for this crisis. In driver-assistive truck platooning configurations, drivers in trailing trucks can theoretically switch to a dedicated rest mode. This allows their strict hours of service clocks to officially pause while the vehicle continues moving down the highway. This incredible feature enables a single convoy to run 24 hours a day, 7 days a week, without violating strict labor laws or compromising human well-being. By effectively amplifying the productivity of a single lead driver, fleets can move significantly more freight with fewer personnel, directly combating the crippling labor shortage. And then, of course, there is the paramount issue of safety and eradicating human error. Human error, whether it is distraction, drowsiness, or simply delayed reaction time, is the primary cause of over 90% of all road accidents. A 40-ton truck colliding with passenger vehicles is almost always catastrophic. Platooning systems support the human driver by providing literal superhuman reaction capabilities. Advanced safety features such as forward collision warning, lane keep assist, and active braking systems are completely foundational to the platoon. In the event of a sudden, unpredictable obstruction on the road, the invisible digital tether ensures that the entire convoy decelerates perfectly simultaneously. This entirely eliminates the risk of rear-end collisions within the platoon itself and drastically reduces the overall likelihood of striking external obstacles. The National Highway Traffic Safety Administration even suggests that widespread, mainstream adoption of these automated technologies could eventually reduce highway trucking accidents by a monumental 90%. Now, let us look at the current landscape, which we can call the era of driver-assistive truck platooning. While the ultimate futuristic vision is a sprawling highway populated by fully uncrewed robot trucks, the actual reality of the mid-2020s is firmly rooted in driver-assistive truck platooning. As of 2025, this assistive model dominated the market with a massive 95.1% share, and for very good reason. Transitioning to fully autonomous operations requires absolutely immaculate road infrastructure, perfectly predictable traffic patterns, and comprehensive nationwide regulatory approval, absolutely none of which currently exist on a truly global scale. Driver-assistive technology elegantly sidesteps these massive hurdles by keeping a highly trained human securely in the loop. In this setup, a human driver operates the lead truck, making all the complex, nuanced decisions regarding navigation, tricky lane changes, and interaction with entirely unpredictable passenger vehicles. The trailing trucks, while fully capable of autonomous following, braking, and steering, also have human drivers sitting right behind the wheel, perfectly ready to instantly take back control in the event of a catastrophic system failure, extreme weather conditions, or simply when the platoon needs to strategically decouple to exit the highway. Major industry heavyweights such as Volvo Group, Daimler Truck, MAN Truck and Bus, and specialized tech firms like Peloton Technology have successfully made the leap from closed track testing to real-world, active deployment. Massive pilot programs across the United States Interstate 80 corridor, the highly congested Texas Freight Triangle, and Europe's crucial A2 route have absolutely proven the viability of the technology. Today, cross-border convoys are actively moving essential goods from inland manufacturing hubs directly to major shipping ports, consistently validating fuel savings of 10 to 14% in fully active, highly mixed traffic environments. However, the road to tomorrow is not completely clear. Let us talk about the roadblocks, speed bumps, and massive challenges that lie ahead. Despite all this incredible momentum, the road to widespread, fully autonomous platooning is fraught with incredibly significant technical, regulatory, and social challenges. The first major hurdle is the terrifying cybersecurity threat. A wirelessly connected convoy of 40-ton vehicles is naturally a prime target for devastating cyber attacks. Increased vehicle connectivity inevitably exposes these platooning systems to potential data breaches, dangerous signal jamming, or completely malicious hacking. If a bad actor were to successfully spoof the V2V signal, they could theoretically force all trailing trucks to brake abruptly or accelerate dangerously out of control. To aggressively combat this, the logistics industry is currently investing heavily in military-grade encryption, decentralized edge computing, and highly reliable redundant analog failsafes. The ultimate goal is to completely ensure that even if the vital V2V link is intentionally severed, the onboard radar and LiDAR systems can immediately, safely bring the massive truck to a controlled stop. The second challenge is the regulatory and infrastructure quagmire. Logistics is inherently borderless, constantly crossing state and national lines, but regulations certainly are not. In the United States, a single truck traveling from California all the way to New York passes through dozens of different state jurisdictions. Each state has its own Department of Transportation rules regarding legal following distances, automated driving systems, and complex liability laws. While some progressive states have fully embraced platooning as an incredible tool for economic growth, others still retain archaic laws strictly forbidding trucks from tailgating under any circumstances. Creating a fully unified, nationwide, standardized legal framework is undoubtedly one of the absolutely highest hurdles facing the industry right now. Furthermore, our legacy infrastructure, which includes poorly marked lanes, unusually narrow bridges, and archaic, outdated way stations, must be completely upgraded to interface seamlessly with modern V2I technologies. The third major challenge is the mixed traffic conundrum. For the foreseeable future, autonomous truck platoons will be forced to share the open road with human-driven passenger cars. Human drivers are incredibly erratic. They consistently speed, weave aggressively between lanes, and make wildly unpredictable decisions. One of the absolute most dangerous scenarios for a platooning convoy is the cut-in, which is where a passenger car attempts to dangerously merge right into the small 30-foot gap between two platooning trucks. Advanced safety systems must be meticulously programmed not just to simply maintain following distance, but to completely intuitively recognize aggressive human driving behaviors, safely and temporarily brake the platoon to allow a car to merge, and seamlessly reconnect once the path is fully clear. Handling highly dynamic traffic swiftly and completely accurately without jeopardizing the physical stability of the platoon is a major, highly critical area of ongoing scientific research. Finally, there is the massive challenge of extreme weather and environmental conditions. While modern artificial intelligence is absolutely brilliant in clear, sunny conditions, its reliability drastically plummets in blinding snowstorms, torrential rain, or exceptionally heavy fog. Optical cameras can be completely blinded by sun glare or completely caked with heavy mud, and incredibly expensive LiDAR lasers can actually scatter when they hit dense snowflakes. While 2025 sensor technologies have incredibly achieved 95% reliability in highly adverse conditions, that remaining 5% represents a highly critical, potentially fatal gap. Until advanced sensor fusion algorithms can flawlessly interpret physical reality in the middle of a blizzard, platoons will firmly remain highly dependent on human intervention during severe weather events. But this technology is not just stopping at massive freight trucks. Let us look beyond freight and explore the expansion into urban transit and personal passenger mobility. While massive Class 8 freight trucks are absolutely the undisputed vanguard of the platooning revolution due to the incredible, massive economic incentives, the technology is rapidly beginning to bleed into several other mobility sectors. The automotive platooning system market is rapidly expanding to heavily include light-duty delivery trucks, massive ride-sharing fleets, and even public transportation networks. In highly densely populated urban corridors, small light-duty trucks are currently running extensive pilot programs to optimize tricky last-mile delivery operations, perfectly synchronized with smart traffic lights, and heavily alleviate crippling inner-city congestion. Furthermore, the incredible concept of dynamic passenger platooning is rapidly gaining massive traction among automotive designers. I want you to imagine a near future where individual, fully autonomous passenger pods, which you could simply hire for your morning commute via a smartphone app, physically or virtually link up on the massive highway to automatically form a temporary high-speed train. By doing this, they perfectly share the incredible aerodynamic benefits and drastically reduce frustrating traffic jams, before seamlessly uncoupling to precisely deliver each passenger to their own specific destination. This incredible concept completely blurs the traditional line between personal vehicle ownership and massive mass transit networks, beautifully offering the wonderful privacy of a personal car combined with the extreme efficiency of a high-speed bullet train. As we look forward to the road to 2035, we are staring at the dawn of the fully autonomous ecosystem. The nature of platooning is going to undergo a truly radical evolution. The driver-assistive models that heavily dominate today will entirely give way to incredible Level 4 and Level 5 fully autonomous operations. By the early 2030s, we will witness the establishment of dedicated, massive autonomous freight corridors. On these highly intelligent highways, advanced infrastructure will actively communicate directly with the platoons, dynamically and safely routing them entirely around construction zones, accidents, and severe weather anomalies in real time. Advanced artificial intelligence-driven logistics platforms will effectively act as brilliant air traffic control for these trucks, dynamically forming and safely dissolving platoons totally on the fly. For example, a fully autonomous truck safely carrying complex microchips from Austin might smoothly merge with another truck carrying fresh produce, all the way from the Rio Grande Valley, right on Interstate 35. They will seamlessly travel together in an aerodynamically perfect, fuel-saving slipstream for over 500 miles, before safely and smoothly decoupling at a massive highway interchange to head directly to their respective distribution centers. The widespread global rollout of edge computing will fully allow these platoons to quickly process massive data loads locally right inside the trucks, rather than heavily relying purely on distant cloud servers, effectively and safely eliminating critical latency completely. Furthermore, incredible zero-mass active flow control technologies, such as effectively utilizing manipulated airflows and incredibly smart aerodynamics literally on the actual vehicles themselves, will further optimize incredible drag reduction without the dangerous need for extreme physical proximity. This will brilliantly solve the terrifying risk of physical instability caused by dangerous external crosswinds. Ultimately, the entire human workforce will permanently shift. While natural human fears of massive job displacement are highly valid, this major transition will be quite gradual. By the time we reach 2035, the traditional role of the truck driver will completely evolve into a highly skilled fleet manager or logistics technician. These highly trained professionals will carefully oversee the physical health and complex software systems of multiple autonomous convoys, entirely from extremely safe remote command centers, operating very much like advanced military drone operators do today. To completely sum everything up as we look toward the networked horizon, vehicle platooning is so much more than a simple, clever exercise in highway tailgating. It is a highly sophisticated, beautifully multidisciplinary engineering marvel that perfectly addresses the absolute core crises of modern global logistics. It attacks soaring fuel costs, fights devastating environmental degradation, shatters massive supply chain bottlenecks, and actively prevents the devastating human toll of horrific highway accidents. As the invisible digital threads deeply connecting all of our modern vehicles rapidly grow stronger, the physical distances between them on the highway will continue to dangerously shrink, but it will be safe. The fully autonomous freight convoys of tomorrow will smoothly move across entire continents exactly like life-giving blood coursing through organic veins. They will be totally silent, incredibly efficient, and perfectly, beautifully synchronized. We are truly witnessing the end of the brave, solitary human driver fighting against the endless wind, and the incredible dawn of the fully networked hive mind, moving together as one brilliant entity toward a significantly smarter, fundamentally safer, and infinitely cleaner transportation future. Thank you for tuning in to G Fun Facts Online.